que pasa es que luego lo oyes por el streaming y es una locura. Bueno, buenas tardes. Bienvenidos al primero de 2 meetup que vamos a tener esta semana. Esta semana sabéis que va a ser una semana interesante porque tenemos dos meetups, aprovechando que tenemos visitas para el próximo Bridge. Hay speakers que van a ir viniendo al próximo Bridge, entonces bueno, pues hemos aprovechado un poco la oportunidad. En este caso tenemos a Mary Grigleski, que viene de Chicago. Ella es una de las líderes del Chicago Java User Group, y en realidad hoy nos va a hablar de distintas comparaciones o distintos sistemas que tenemos reactivos, ¿vale? Así que yo creo que vamos a aprender todos bastante, y luego sobre todo prestar atención porque sabéis que tenemos una sorpresita al final del meetup, o sea que todos con los oídos bien atentos. So Mary,
yes,
welcome to Madrid.
Thank
you for coming.
Thank you.
And they are all yours.
Thank you. Yeah. Actually, first of all, I'd like to take a selfie of the audience. Yeah. So yeah, I'm starting to do it because I think we're trying to do some facial recognition to count people. We haven't done it yet, but we're trying to do that. So yeah, I'm starting to take pictures. So yeah, and then try to get as many of us in. Okay. Yeah. Actually, my hands are not long enough, but yeah. Okay. Yeah. Okay. Okay. Maybe not everybody, but at least a majority of you. Thank you. Okay. Okay, so I'll begin. My name is Mary Grigleski. By day, I'm an IBM developer advocate, so I travel part of my job is to travel and then talk at user group, talk at conferences, and my specific area is with Java developer advocacy. And also too, then my specific area is kind of 3 months ago, I was told, hey, I start working on the reactive systems. Basically, IBM has a partnership with Lightband. So there's Aka Lagom that we're doing some work on promoting too. So that's kind of my job. And yeah, so bear with me too. I'm also new on this subject matter, but I started working on this too, and also have some plans of running code and coffee, maybe online. That's something I'm also experimenting with if folks want to learn together, kind of code together type of things. So, but anyway, so by night, I'm a Chicago Java Users Group organizer too. So I organize meetups. So it's really great to see all of you here. It feels like myself too back in Chicago too. I run meetups twice a month too. So it's very active. And we have 2,750 members. Although every time maybe around 80 people sign up for something, and then only 50% show up. I don't know what it is. Maybe there are other meetups that are around, other technology, the cloud, the AI and machine learning are also kind of stealing some of our participants. But so we're trying to get Java back into a very active kind of community to build this up right now. So I'm from Chicago, but I travel around, and I also work with, and I've only been with IBM for about 7 months so far, so it hasn't been that long. But I've been a developer, or prior to this, I was more doing development, software engineering for quite some time. But for Java, I started out in year 2000. So on and off, and then I moved to Chicago in 2014. Then I worked for companies like Chicago Mercantile Exchange. So there are some trading firms and some of the regulatory information systems too that I work on at Chicago Board Options Exchange, and then some manufacturing too in companies in Chicago. And then prior to that too, I first started with Java when I was in California. I actually was working on Power Builder. I don't know if you have heard of that, right? That's when I first joined Sybase back then. Sybase just merged with PowerSoft at that point. I joined them in '97. Then I got a chance to transfer within PowerSoft, and then PowerSoft became Sybase, and then that's when I got recruited to help out with the J2E development group too. So that's a bit of my background, just to give you an idea. So, but then in recent years too, I also started getting into some hybrid mobile app, like some JavaScript and Python as well too. I think we are all these days are really like polyglot. We're not just doing one thing. We're like so many things now. The cloud, machine learning, AI, everything, and they all kind of blend together, and we are called to do whatever it takes to deliver systems. Yeah. So anyway, so enough of myself. So today my topic is on reactive Java, and it's a really I call it like a gentle introduction. So this is really kind of for more folks who are not as familiar with reactive programming and systems. So it's really an introduction. And may I ask too, how many of you have been working with reactive Java programming so far? So yeah, so actually that's cool. That's quite a few of you too. Because I was just in Rome, and the MadridJUG there, not many people have worked with reactive systems yet. Maybe like 2 or 3 that are kind of more familiar with it. But I think different areas have different focuses too. And even in Chicago too, my group too, there are not as many people working with reactive systems yet. And I think probably it's going to take some time because it's a shift in thinking from imperative programming that we're so used to like doing declarative programming, async and event-driven programming. So bear with me if I'm repeating something that you already know, but just so you know too, for some of you too who are new, I hope to give this as an introduction of reactive programming and get you excited to want to learn more about it. So today too, I'll talk about not just the reactive programming, but there's also reactive systems, and they are different, not the same. And also I'll give like just a comparison between 4 popular Java tools and libraries that are RxJava, Spring Reactor, Akka, and Eclipse Vertex. Okay. So first of all, like why reactive? Okay. And okay, let me see. Okay. So basically too, there are evolving changes in the hardware level, as we all know. There are like more CPUs now. Their clock speed has increased over time. Multi-CPU, multi-threading, all of these hardware that basically software needs to kind of catch up with and be able to utilize the hardware to basically take advantage of this capability in hardware. That's one thing. And then of course too, in recent years with virtualized containerization, like computing infrastructure too, so there are multi-cloud strategies. All these are really basically enabling reactive programming to kind of come into the foreground. And of course too, as distributed and virtualized computing infrastructures have become mainstream and multi-cloud strategies becoming realities, and software systems too are catching up with the new constructs too. And not only that, I think as human beings too, we are very impatient. Essentially, reactive systems means being very responsive. Requests are being sent to systems, and systems need to respond really timely fashion. So it's kind of actually more intuitive for human beings. But to do programming too is on another level is more difficult in some sense too. So, okay. Oops, I think I go a little too fast. So now I'll go into like reactive manifesto. This I won't go into like too much detail here, but I do want to point out the site for where you can get more information. So reactive manifesto is basically the guiding principle, and it's also of reactive programming and actually more reactive systems. And it's led by Lightband, the company where Martin Odersky, the Scala inventor, is leading. So they actually help and lead this effort to define a set of guiding principles for doing reactive programming. And the latest version is version 2.0 and came out in September 2014. And it promises more flexible systems and that are very highly responsive. And not only that, it's really tolerant of failures. And the way it handles failure is also becoming more sophisticated than the traditional programming style. Okay. Oops. Okay. So this diagram too is, it comes out of a lot of the reactive talks too. I'm sure some of you are familiar with it already. Essentially, there are 4 principles, core principles of reactive systems. What define a reactive systems is that, first and foremost, it has to be responsive. As I mentioned just now, it means that requests are being sent to the system and the responses have to come back in a very timely fashion. And not only that too, when we talk about resiliency is how systems will handle failure and being able to be also responsive. Failures occur, then there should be also like prompt response to handle failures as well. And being able to recover from the system, from any kind of system failure situation, as well as also in, say, for sophisticated reactive systems like ACA, and also other systems too, that actually, in ACA, it has this capability called supervisor, that it provides the self-healing kind of capability in it. So if there are problems that occur in the systems, then the components themselves ought to be able to tell the supervisor of the system. In an ACA system is the actor model, that actually the actor acting as supervisor will basically respond to like a component telling it that, okay, I'm in trouble now, I can't digest all the requests coming in. Then basically the supervisor has to do something, increase the resources to handle all of the requests, for example, or maybe slow down and control the flow. That type of scenario. So that's essentially it's resiliency. It's what it means to being able to do that kind of handling too. And then actually also then elasticity too. Okay, actually just now what I talk about is more about elasticity. Elasticity meaning that systems is able to respond to loads, increase the number of resources to handle, scale up when there are more requests coming in, and then scale down when the system requests are slowing down. Then you don't want to waste any kind of resources, and it's being elastic. Basically the whole throughput of a system should not be affected by too much. You know, you get too many requests coming in, basically the throughput should remain more or less the same, is what elasticity is. And then in order to be able to support all of these three principles, basically a system needs to be also like message driven. So message driven means that it provides, okay, so in reactive systems, basically all of the components are isolated in time and space and the resources yeah, so then like all of the components are being separated out, and in order to communicate between all these components, they are all message driven, and it's also asynchronous in nature as well. They are essentially non-blocking. So the message driven capability is a really core principle in basically kind of like define reactive systems. And also in message driven too, it also has an addressable component to it too. So in a good reactive systems itself, it actually will take care of location too. So then on the application level, you don't need to worry as much about the address where like messages are being sent to. It's basically the framework, the toolkit should actually handle that part too in a reactive systems. So, okay, so some important distinctions. So over here, I'm just using this picture because I just wanted to show it's like a basket of fruit. You can tell there are different kinds of fruit. So I wanted to point out that reactive programming is not the same as functional reactive programming. So essentially, in reactive programming, the way the control is being driven forward, the flow is basically the control is kind of driven forward by basically the availability of information. So if any kind of data changes, then it will drive the control flow to flow forward, basically. Whereas in functional reactive programming, is basically it's the thread of execution. That the thread keeps executing, and that's what is driving the flow to go forward. So that's an important like distinction between the two. So they are not the same. And then in reactive systems, an architecture is essentially another level up, meaning that it's abstracted out. So reactive programming, we're dealing with some components that are you're coding on that level, that you're coding and they're handling all the events. But then on the reactive systems, we're basically bring the system up one level. You're handling the system as a whole as an ecosystem. There are many components that are running, and you have like message-driven capability that are in a reactive systems that handle the responsiveness, the resiliency, and also the elasticity of the whole ecosystem in there. So, yeah, so I hope it makes sense. If I'm going too fast or not clear, please feel free to ask too. Because I do have to admit too, I just flew in from Rome there, and I got up real early this morning and didn't have much time to rest, so maybe my mind is a little bit off. So please bear with me. So, okay. And here, I just want to also point out too is about event-driven versus message-driven. This picture, actually, this diagram I took from Lightband too. So there are differences between like event-driven. So in the event-driven system, it's basically not concerned. Messages that are being sent are not like destined for any any kind of destination. There's no addressable component to it. It's like a soapbox, you know, I have something. It's like the old PubSub model, right? Asynchronous. So there you have messages coming out. It's being, like they are just events being kind of sent out. And so it's up to the observers in here. They are interested in subscribing to these events. Then they will probably do something about the certain events that come out. So that's the main kind of differences. So it's like taking like a soapbox approach. Whereas for message-driven systems, they, again, I also point out earlier, is that message-driven here, instead of using over here, I actually put in just another image over it, is like envelopes. And think of they are just like envelopes with the address, like you send an envelope in a mail to somebody. So you have a destination for where the messages should be going to. So it actually has the addressable, who is going to receive it and where is it going to, and also some single purpose too. So those are like kind of important distinction between event-driven and message-driven in here. And how many of you have actually done WSDL, right? The SOAP messaging, right? Yeah, so SOAP, it's kind of same ways too. SOAP itself has an addressable kind of envelope to it too. So it's kind of like that too. So, but kind of old, you know. SOAP is kind of old, but they're still being used, I believe. Yes. So the WSDL, yeah, I worked on it before. So, okay. Now, instead of being kind of too boring, so I thought, okay, let me kind of pique your interest a little bit about this topic. So you'll be thinking all these like concepts, especially for someone new to this. It's like, well, how, you know, where can we be using this reactive programming approach? So I just thought of this use case because I was actually in Tokyo in December for a Java users group. They have an annual, actually they have twice a year. The Java users group there in Japan, they kind of combine together. It's about 1,000 people that they have a conference in the fall and then a conference in the spring. So I went to the one in December. So I was in Tokyo. Anyway, so I went to a ramen shop, and then it's actually quite interesting. Everything is actually in there. It's kind of manual. You go inside the restaurant, there are no tables or chairs like what we tend to be used to, right? You go in, basically there's a vending machine, but only one machine, and it's all like, you know, you have to line up. And then sometimes with a really good ramen shop, you got like 20 people. That's where I was. Actually, that evening I was there. I was like hungry for ramen. And so I line up. It was like 20 people. And then you have to stand there in line, wait for your turn, punch in your orders. And then you get a ticket. And then, of course, too, I did not understand Japanese. I'm actually Chinese by ethnicity, but I can understand Chinese but not Japanese, except a few words that are in kanji. So I was like kind of pointing and don't know what it is, and then have to get some help and then order. In the meantime, I got my ticket, then I have to wait in line in order to be seated because the bar area where you sit around the kitchen area is very tight. There are probably only 20 seats, a tiny noodle shop, and you got probably like 7 or 8 people serving. Some are cooking noodles, some are doing this and chopping like vegetables, whatever. And so like, it makes it kind of, in some ways it's inefficient because think of it as like a blocking on a computing level. It's like you're blocking. You have an order and then you have to wait. In the meantime, you can't do much, right? You're just waiting there for your table, waiting for your noodles. So that gives me some idea, that might be a good use case to kind of employ the reactive programming approach, which I will talk about in a little bit. But first, let's get back into some like boring things first, which is just, not too boring, but just get back into some of these kind of more theory and kind of concepts. So just want to talk a bit about reactive programming first. So some of the patterns and terminologies. So reactivity, here you have heard of the words. Let me kind of take a look at some notes to make sure I don't say the wrong thing. So reactivity is really the process of responding to external stimuli. There are some stimuli, like events that comes in stimulated. Some events happen, and they're also propagating events too. They're events that are happening, and it changes in state. The data gets transformed. They are really, that's what defines like reactivity. And the events themselves are stimuli. It stimulates the timeline, and then some action needs to happen. It's expecting some action to happen. And then streams, and streams are really primitive representations of a sequence of data elements. So we're talking about kind of like more, streams of data that flows through the timeline. And then we also hear about observable, especially in RX Java, they use a lot of like observable. Observables are really like stream of events, essentially. So, and then there are some of the common design patterns in reactive programming that are used. There are observer pattern and composite and iterator. Those are the three common patterns. So here, and then I wanted to also talk a bit too about a bit of conceptual of reactive programming, but using RX marble diagram. Some of you may already be familiar with it too, so just bear with me. But over here too, we're in reactive programming, we're talking about timelines. So in the very top one, this is just a timeline. And over here too is just the timeline, but no events is happening. And the second one here, you see that there are different shapes. So these are the marbles, different shapes. They represent events that happen, some data that comes in. And over here, you see that there's a perpendicular line. It means that the stream has terminated. That's what is signaled. So, and the third one down here, you have events that happen, and there's like an X. And notice that this is an X. It actually is. It explains that any kind of failure that happens in a reactive programming systems is that failure are being treated, or fault kind of events like that, they are being treated as first-class citizens. They are no different than normal events in here. They also like exist on the timeline. But the difference is that maybe when an error occurs and something needs to happen, it tells on the application level something needs to, somebody needs to deal with it. There's some handler. So as opposed to like in Java programming, we will have to do a lot of try-catch, and kind of makes the program quite ugly, actually. But then if you think of like in reactive programming, then basically the error are just events. So you have to like deal with it, basically. And then over here too, this is what it is indicating is that you have like events that are happening, these marbles on the timeline, and the stream is open-ended in this case. So it's not terminated or nothing has happened in here. So this is just a basic representation of reactive like events in the marble diagram timeline. So. And here too, I wanted to also use an example too. So in reactive programming too, we have here I'm using an operator. In reactive programming, we call these operator. So what it does is it operates on the data. It transforms. It needs to be doing some transformation to the input. So here I'm just using this very common operator is map. So the map, what it does is it just transforms the data. And this example I'm using in here, basically you can see a timeline, and you have 1, 2, and 3. These are like the events that happens there, contains the data. And the transformer in here, the map, will basically take in the input and then multiply the input by 10. So that's the transformation, this function in here. And then you see this timeline in here is that after transformation, the 1 will becomes 10, 2 will becomes 20, and 3 is 30 in this case. So this is just a simple example to illustrate. On the coding level, look at over here, is using an observable, and basically you take in the stream doing a dot just. Here, in this case, we'll take in the input 1, 2, and 3, and you apply the transformer to it, the map, and you basically then specify the function in here. It does a transformation of 10 times x, whatever the data value is. And then immediately, too, then we do a subscribe. So it's like the consumer of what gets transformed is right there, too. And then in this particular case, we're doing a timber.d, which is just sending the output to the system output console in this case. So just want to point out, too, if it is in like traditional programming sense, is that that will require more lines to kind of, okay, take in the input, and then, you do some of the operators, for example, is like filter, can actually do kind of beauty in programming too, because you can just apply a filter to something, like if the data coming in is an age greater than 20 or less than 10 or something. Think of on the programming level is a lot more elegant too. So in Java 8 that's when it's making like functional programming and reactive programming a possibility because of streams and functional programming capability in Java 8. But over here too, this is just an example. And also to look at over here, you can do everything in one single command statement. Altogether, they're chained together. And then over here too, you can, this is just an output. So what you would see is that an item becomes 10, and the second one is 20, and item is 30 in this case. And if you want to have more too, you can go to this website, https rxmarbles.com. It also has some more like examples too that you can play around with some of the other transforming operators to like filter, flat map, for example. So like map is actually will just convert like concrete value A to concrete value B, but flat map means that it will just flatten it in from a concrete A into some stream, for example. So there are many other operators too that you can look into that you find it to be quite elegant once you get used to how to use it too. Okay, so now I'll go into a bit of reactive systems design. I won't go into like a lot of detail, and the reason is that it actually gets quite deep into some of these patterns too. If you're familiar with it too, over here. So essentially, again, reactive systems, we're handling like a system as a whole, a bunch of components interacting with one another. You should have capability, directives of kind of coordinating all of the actions and events that are happening in all your components. So basically, too, there's a book too, actually, that somebody, I forgot the name, but somebody from Lightband or affiliated with Lightband, he wrote a book quite recently. It's called Reactive Systems Design. So this is just what I kind of took from there too. So there are a set of patterns that are divided into managing the state, and persistence. There are flow control patterns and message flow patterns and fault tolerance and recovery patterns, replication, and deals with resource management. But this I won't go into details because you can spend the whole night or years or months talking about it too. But I want to point it out to you, so if you're interested, you can look more into that too. Oops. Okay. So here too, some terminologies. Over here too, I just want to point out reactive microservices versus like monoliths. As you know, currently, actually, oops, oh well, doesn't seem like it's pointing too good. But anyway, I was just going to point out too, as you know too, I'm sure some of you too probably are still working with systems that are older, that are monoliths, that are like maybe one giant systems, one that have all components inside one JVM or something. So you can imagine it's actually very hard if you want to do any kind of upgrade or expand your database, expand your table, or whatever it is. So the idea is that we want to break up systems into like a smaller chunk, bite-sized chunk that you can easily kind of upgrade them without affecting the other pieces. So that's the idea. And then over here too, the reactive microservices is basically applying reactive programming techniques and system level to manage these microservices. And essentially too, reactive systems takes care of like isolating the state, the space, the time, and the failure of any kind of systems. Some of the common patterns, earlier I talked about those patterns category, but I just want to point out a couple of interesting patterns that a good reactive system should have is basically circuit breakers. So circuit breakers, the idea is that it's just like the electronic circuit breakers too, right? So if there's any failures that occur, the system has to have some mechanism of basically stopping the failures of persisting itself. It needs to basically stop that and basically break it. And some actions needs to happen. So you stop failures from keeping to propagate itself. So that's kind of idea of circuit breakers. So that all reactive systems should have too, properly speaking. And then there's also a back pressure. Back pressure essentially is if there are too many requests coming in, and so some component is handling it, and then basically it can't handle it in time because you get too many back pressure essentially building up of all these making the components choke essentially. I can't go on now. I'm kind of having too many things to do essentially. So basically back pressure. So a very good reactive systems design or a framework should have really good back pressure mechanism to manage these, and maybe you increase the number of components to handle requests as they come in, and rather than having only like fixed number of components handling requests, for example. And then there's also high availability. So high availability essentially it supports like responsiveness in reactive systems too. It means that requests coming in and responses should become like highly like available. And so it's basically meaning requests should actually happen or it should come back like on time for the requests that are requesting it, right? Whoever is requesting it. And then there's also this idea of eventual consistency too. So eventual consistency, you can go into more details reading it, but essentially too, we're talking about data itself. So sometimes because of high availability, we want like response to come back faster. But in order to come back faster, that means you probably will have to sacrifice the time of doing some verification on your data. And that is okay, because we believe that even though you have requests coming in and you want to return some data back, some response back, and the data may not be accurate, but we believe that eventually the system will fix itself. The data will become consistent in the long run, is what it is. So in some ways too, high availability and eventual consistency, they kind of like juxtapose each other. They kind of oppose, because you want things faster, then maybe what you will get back the data may not be as accurate. But then it's okay, because eventually when you do it enough times, then the data comes back will become accurate, is what it is. So, okay. And here I also wanted to point out two reactive streams, and this is a specifications that comes out to, currently it's at 1.0, and that was latest releases in August of 2017. It started up as a working group in 2013 by Netflix and Pivotal and Lightbend, and later they are joined by Oracle, Twitter, Red Hat, and Spray.io too. So essentially this reactive streams, it is a standard for asynchronous stream processing with non-blocking back pressure is what it is. And basically too, the Spring reactor, which I'll talk a little bit later too for one of the libraries, they have full support of the reactive streams in there too. And the initial release, so they started in 2013 and they initially released it in 2015 in May, and then latest release is August 2017. So now how about like microservices? So how are microservices related to reactive programming and also reactive systems? I'll just give this, just read I have some notes in here. So reactive programming essentially is used within a single microservice, and it implements a service internal logic, and also manage the data flow. Think of it more like a smaller scale. I'm handling one thing, and that's the reactive programming part. And then reactive systems, they are actually okay. So so basically, the reactive programming is being used in between the microservices that will bridge the communications by the underlying message-driven capabilities. So then it basically enables responsiveness and resiliency and scalability, elasticity in systems. So those are the differences between the two as they relate to microservices. Okay, now let's slow down and spend some time observing. I just saw this, I thought it was interesting, because we use the terminology of observables in reactive programming. I saw this, I thought it was interesting. We're supposed to slow down, but then in reactive programming, we're supposed to go faster because we want to respond to requests faster. So I find it interesting. I just put this quote in here. So, okay, so now let's go back to my use case. So I just wanted to kind of resume that part a little bit, maybe waking everybody up because we're hungry, getting hungry. So over here, earlier I talked about how you go in, you order your food and your noodles, and using one machine and handles one request at one time. And you put in your money, and it doesn't accept credit card too. And then you get back a ticket, and then from the ticket you give it to the server. The server then will go prepare your noodles. In the meantime, you have to line up. There are 20, 30 people line up for your seat to be available. It's usually more people waiting in line than there are tables available. But that's what maybe make the noodle shop good and make everybody wants to go back too. So, yeah. So, okay, so that's just some like background of these noodle shops. So here is just what I'm thinking of doing a use case of this reactive testing out and implementing using the reactive programming approach. Is basically do a mini like kind of ordering system. So meaning over here, like I cannot use this, but so basically over there too, like there are customers, the purple little people, there are customers going in. I want to place order. So instead of me going in and punching a vending machine, I'm thinking of just using a mobile app, like as a user interface. So you can download your app and then order your noodles. So once you order, you place the order, it becomes like an observable. It's an event that needs like a stimuli on your timeline that something needs to happen. So basically, what needs to happen is that the observers, which are the waiters, waitresses in here, they are observing, okay, there are orders coming in, I need to do something. However, in a noodle shop, we can't do anything yet because there's no seat available. So then that's a kind of an added responsibility for the observers, the waiters and waitresses. They need to actually make sure there's open seat before you can actually submit your order to the cook to cook it too. So then I have another observables in here. Is basically that one will kind of indicate if there are seats opening up. And then basically it's telling it, okay, there's an open seat available. Then the waiters, whoever is managing that, should see, okay, there's orders, there is somebody, customer A placed an order, then there's open seat available, okay, one person, so I can then map it up, okay, ready. Then in this case, then I basically can then tell the cook to go and order, cook the ramen. So think of this fact that you are probably busy, everybody, doing programming, and then you're getting hungry. You're saying that, okay, I want a bowl of noodles, so let me get my app and then punch in and order this. In the meantime, the operation is non-blocking. You punch in your order is being sent, and you're just basically waiting for some notification to happen. But then you can continue programming too. So in the meantime, you don't waste your productivity. You're doing that while the noodles and all the waiters are servicing your order. And when seats are open, then basically the waiters will then have to say, okay, well, I have seat open now, very soon, or maybe in 5 minutes, something like that, give you advance warning. So you're saying, okay, cool, let me compile my program. Okay, good, it's good. At this point, it's good. I know my noodles coming up in 5 minutes. So in that case, then you can then basically get ready, get dressed, and then go to the noodle shop. And then when you walk in, you basically have your seat open up and also have your noodles ready. And basically, too, at that point, too, after you submit the order, I forgot to say you are an observer. Basically, you are observing. Basically, you're waiting, too, for noodles to be ready, and you are being notified, too. So again, this is just an example, is in a very high-level sense. Of course, if I go to implement it, there will be a lot more details that I need to handle. But that gives some idea of where we can apply a reactive programming paradigm to implement a system like this. So, okay, so now I'll then go into the final part of this talk, which is about the 4 libraries that I mentioned. And basically, RxJava is really a Java implementation of ReactiveX, Reactive Extension. Reactive Extension was started actually by Microsoft. They implemented Rx.net first. And then it's very popular, especially on Android. And then it's also available in JavaScript, the other languages. It's actually quite popular too, if maybe some of you already are working on it too. And then in version 1 that came out is basically before the reactive stream specification came out in 2014. But then in 2016 it came out, there's basically the flowable came out and basically replacing the observable. And then it also provide like back pressure capability. So it's becoming a bit more, not just the reactive programming, but getting more into the reactive systems aspect of like reactivity. And so just a quick example of Hello World. Just think of here is actually quite clean because all you need to in here, just think of traditionally you have multiple lines that you need to do a static void hello or main and then parse your arguments and everything. But over here is just one line. It's flowable, do a dot from array, take your arguments and basically do a subscribe right there. And the subscribe basically is the consumer. So what the subscribe is doing now is that it does a print out, system out print line and basically do a hello and then take in the argument in this case. So you can tell it's a lot cleaner. It's only one command statement that handles a lot of things in there. Okay. Okay. So here is another example. This is more just like showing you. Probably I already talked about it too, but just thought I'd show too. Is that an Rx Java 2 example? In here is that over here is the observable doing a dot just and takes in that input, that stream, 5 elements in here. And the consumer, what it does is, in this case, is doing a system out print line. And how do you attach the producer to the consumer is doing a observable dot subscribe and then take in the consumer. That's how you kind of attach the producer to consumer. Okay, now I'll move on to Spring Reactor. Spring Reactor is based on Project Reactor from Pivotal. It's very similar API to RxJava 2, and it's built for Java 8 and over, allowing for more cleaner interface. So essentially, Spring Reactor takes advantage of Java 8's functional programming and stream capability. And it's actually similar in API to RxJava 2 is because the project lead of RxJava, David Cannock, is also contributed to the Spring Reactor project too. And over here, I just quoted one thing that he said is that if you should use Reactive 3 if you're allowed to use Java 8 plus or over, and then use RxJava 2 if you are stuck on Java 6, or if you need your functions to check exceptions. Yeah, basically, then use RxJava 2. And that's quoted from 2016, and it's a bit older. So these are like basically the libraries of Spring Reactor. The core is what we use for doing the programming part. And then there are other libraries that are doing testing, the extra additional capabilities, and then it has very good integration with Netty, Adapter, Kafka, and RabbitMQ. Also, they're also incubating reactive streams, foundation for .NET and JavaScript as well. Okay. I think looks like maybe the battery is not working now, so I'll use my this. Okay, so over here too is an example of Spring Reactor, Spring Web Reactive. So that's the non-blocking web stack. So if you look into the top part, that's the traditional approach. Over here is just a small example. So the top part and the bottom part, the two approaches, they look about the same, number of lines of code. But why I'm showing is that just to want to show what's different behind the scenes. So in the top part, traditional approach is the synchronous blocking approach. So you look at the get all products, you have system out print line doing traditional way started. So when you run your program, the traditional way started will get printed first, and then the second prod service.get products will basically go and fetch the list of products and return that list to you. In the meantime, your method is being blocked using the traditional way. So the get products will be doing its thing, and then in the meantime, this get all products method is actually waiting for the list to come back. So after it comes back, then the third line traditional way completed will get printed like that. Whereas in the bottom, the reactive approach using Spring Web Reactive and the Web Flux is that over here, doing a get all. So the first line is reactive way using Flux started. Then the second line, notice here, is actually returning a Flux. What they call in Spring Reactive Flux is similar to if you go to supermarket. I'm assuming here is the same, but in the US, if you go to supermarket and buy some meat, right, or ham or something, you get a ticket. You go to the counter because the person's serving a lot of customers. So you go there and then you get a ticket and then you wait for your turn. So essentially it's like that too over here. Doing a prod service get product stream and it returns a Flux. It's like a ticket to you. You don't get your result right away. This Flux products is being processed. In the meantime, what will happen is that before you actually get your list of your set of products back, you actually will see the third line reactive way using Flux completed will get printed first before you get the products, the list of products back, because that's the non-blocking capability, the asynchronous way. The call is being handled asynchronously. All you have is like a ticket back, and then later when it comes back, then you'll then take care of what comes back, and then you go and process that accordingly. So those are the differences in here. Okay, so here's just some quick comparison between RxJava and Spring Reactor. They all came out in about like 2017. And the environment is that RxJava is the reactive extension, and Spring Reactor is rely on the Spring 5 framework too. Again, Spring Reactor is started with Java 8, and RxJava actually started with Java 6. They are both single-threaded non-blocking by default and event-driven. RxJava supports reactive streams only partially, whereas Spring Reactor supports reactive streams fully. And earlier, I also mentioned too about RxJava 1 has observable, RxJava 2 has actually this, the observable, flowable too is what it has, and then all these other things, and also many operators too to operate on your streams. Spring Reactor too has the Flux and also the mono. and also has a set of core operators as well. So, yeah. Okay. So now I'll kind of go quickly to ACA. So ACA comes from Lightband. IBM has a partnership with Lightband. It's the alliance formed in June of 2017. It's based on the actor model, and actor model comes from Erlang. It's not a new concept too. It came from Erlang in the 1980s too. And it's event-driven. It supports location transparency, and it's very lightweight. And earlier I talked about it's very good because it also has the supervisor capability that handles failure situations very sophisticatedly. So, yeah. So here, just an example too of Hello World. So over here, I'll show you this main method will create the infrastructure needed for running the actors. It basically starts the main.java. Is a small wrapper around that generic launcher. Launcher in here is the aka.main in there. And it only expects like one argument. And the argument is the class name of the application's main actor. Given main actor and arrange for the whole application to shut down once the main actor terminates. So this is just an example of this. Okay, so here too, let's take a look then into, that takes the one argument, which is the Hello World actor. So the Hello World actor in here is really the application's main class. So when it terminates, the application will then shut down. And we'll talk, there's a bit more to it, but you can also read up in the Aka site too. It has, this is where I got the example from. The main business logic happens in the pre-start method, like below there. So that's where the main logic happens there. So the greeter, basically when in the pre-start you see that there's the greeter, that actor is also another actor that gets created and instructed to issue that greeting we crave for. So when the greeter is done, then it will tell us so by sending back a message. And then when that message has been received, then it will be passed into the behavior described by the onReceive method. So over here too, the onReceive. Okay, there's a create receive, the onReceive method. Yeah. Then yeah. So, but anyway, yeah. So we'll take a look into the greeter method then. Okay. So this is just a simple case, simple usage in here. So this actor will not do anything until someone sends it a message too. So then if that happens to be an invitation to greet the world, then the greeter complies essentially and then informs the requester that the deed has been done. So you can tell too, Aka itself probably involves, in this case, involves a little bit more coding, but it's actually, it has a lot of the underlying capability that handles reactive systems very well too underneath. So, but that too maybe is in my next talk that I'll go a bit deeper into like Aka, some of the deeper concepts too. But for now it's like an introduction to show that to you. So again, this example is Java because my talk is based on Java, so I'm showing it in Java. But over here, if you write Scala too, so this would be how it is being done in Scala too. How many of you actually are working with Scala in here too? Yeah. Oh, so a few. Yeah, one or two. Yeah. Okay. Cool. Yeah. Cool. Yeah. I haven't found too many people doing Scala so far, and most are still working with Java. So I thought I'd ask too. So yeah. So yeah. Okay. So the next we'll be talking about is VertX, which is the last library that I do a bit of example. So VertX comes from Eclipse, and it's very flexible polyglot framework that interoperates really well with other frameworks and tools, and it's the newest among all four too. And it can actually works very well if you have RxJava in there, or even different languages too. You can actually blend very well into VertX too. VertX has a very polyglot kind of framework to it, and that's actually pretty sophisticated in terms of flexibility. So yeah. So and then it doesn't quite use an actor model. It isn't, even though the deployment side of things is similar to an actor model. But what the model it uses is called verticals. So the verticals are really components that are being deployed and executed by VertX. So it is event-driven, and they run only when they receive a message. And essentially, there's the Vertex event bus that are responsible for carrying all the messages around all of the components. Again, it's not restrictively tied to any container, and you can use with other libraries. So it is a pretty promising, flexible framework in here. And actually, okay, so here, so this is just an example for Hello World. Again, it's also, you can tell in here too, is actually quite easy, quite simple in this case. And simple in the sense is one command line. It actually does a lot of things over here. It's in the main. So you just imagine here, Vertex is the engine that starts, and it creates the HTTP server. And basically then you chain it, and the request handler takes in the request, and basically your request will have the response, and basically then do the .n and hello world in there. And it listens and basically binds the HTTP server to port 8080 in this case. So you can tell too, it is pretty clean, yeah, using Vertex. So, okay, so now it comes to almost an end, but well, I'll just do a bit of recap and takeaways from this set of talks. So reactive is really overloaded word in today's market, and don't get discouraged, because even I think first time I've been doing programming for 25 years, but when I first pick up the book on reactive programming, it's actually kind of confusing, the async, the non-blocking. But just don't get discouraged if you're new to it, because it's normal, and it takes your brain a little bit of time to switch from imperative programming to doing declarative programming too. So, but yeah, as I mentioned too, I plan to actually start a online code and coffee. So if you are interested too, you're welcome. Yeah, please to stay in touch and maybe just watch for. I'll be like, okay, watch for me like tweeting. Maybe I'll say I'm going to start a online code and coffee, because right now too, I still need to work with my IBM, the video person, to set up the logistics, how to set up so then like folks can participate. So I just thought I'd give you some heads up on that. So and again, some of the things is just to repeat, reactive programming is not the same as functional reactive programming or reactive systems, and some of the benefits. Okay, blah, blah, blah. And then we'll go to the bottom one. It's actually, I wanted to point out is that reactivity to this day is not really fully ready on the database level. Because if you think of it, all the relational database, they are still using blocking I/O. So none of them are supporting non-blocking I/O yet. So in some sense, systems are not truly like reactive, because in order to qualify as systems and the entire ecosystem as reactive, like every bit and pieces of it should be like non-blocking. But in this case, when all of our systems rely on databases, relational databases, they are not truly reactive yet. However, there are some kind of significant efforts on the connectivity, database connectivity level. So you might have heard of R2DBC from Spring that they developed. I think they support HQL and also MySQL, and also I think MongoDB as well. They are like driver, like that provides like connectivity, to kind of connect to databases. So on the connectivity level, database connectivity level, there's some support of reactive programming. So. Okay, so with this, my presentation comes to an end, and this is how you can contact me. My Twitter handle there, my GitHub, and also my IBM developer profiles there. I can provide these slides to David too, and you can have it if you like. And also here too, I'd like to invite you to, if you're interested, please sign up for IBM Cloud. It used to be called Bluemix, but now we call it IBM Cloud. And there's a free tier access too, and also IBM Cloud supports a lot of open source. Actually, IBM, the company too, as I also come to discover, having been there for 7 months, actually we're big supporters of open source. For example, like serverless, right? We're actually using Apache OpenWhisk underneath the hood, for example. So it's very, very flexible. And some of the NoSQL, we have like Cloudant, which is similar to like MongoDB, or actually Couchbase, for example, things like that. So I'd like to invite you to sign up for IBM Cloud, and also resources to get to the reactive systems at IBM too. We're going to be like increasing more resources in the site too. And then these are just different links to the Lightband information, the reactive manifesto. And also the book that I mentioned about reactive design patterns is the one below. It contains very good like reactive systems design in that book. So. And then just one more thing is that I'd like to invite you all, if you're interested too. IBM also has a initiative, is a multi-year initiative called Call for Code. So if you visit that link up there, callforcode.org, this one is actually a hackathon that has money, prize money associated with it too. We're encouraging folks to form, you can be by yourself or form teams and design systems and apps that are for like disaster, natural disaster preparedness, or any kind of situation is for humanitarian cause. And it has money associated with it. And right now you can submit your code to and come up with some idea how you can have your app be useful in any kind of disaster happening. For example, people that are suffering from that. And you still have time. It's July 29, 2019 is the deadline. So I'd like to invite you to look into that too if you're interested. So, and with that, thank you. I think my talk comes to an end. Thank you for being here. Thank you.
So if any of you have any questions, we have some time to make it.
Yeah. Thank you.
Hi, hello.
Hello.
I would like to know if you can talk a little bit about performance changing to a reactive system.
Yeah, that's actually very good question. I have not got time yet to actually do that kind of metrics, like performance metrics. But that will be my next set of tasks that I plan to be doing when I go back to. It's really like comparing, like using traditional programming, implement some benchmarking, and then also then using a reactive approach to kind of compare the performance benchmarking. So I have not done that yet, and there are not many not many resources on the internet to this day seems to be doing this kind of performance benchmarking. But I like to be doing that. So you ask some very good questions. Yeah. So but I'll keep you posted if you follow me. I'll post something when I have. Yeah. Thank you. So,
Any other questions?
Yeah. Hi. You mentioned that databases are still connecting through blocking I/O.
Yeah.
So, do you think that reactive programming is a bit more interesting in orchestration layer rather than persistence layer or microservices that have to persist data into databases?
Yeah, you asked very good question too. I think that's a question I'm trying to look for some database expert in the field to ask them. But I think right now I'm not sure. Maybe relational databases are kind of old and proven technology, right? So then they're probably no one, or maybe it's very difficult to do non-blocking, so it hasn't happened yet. But it is very true. I think you brought up a very good point, is that maybe reactive system to this day has been mostly like orchestrating components, like message passing between different things and orchestrate, it's like an orchestrator. Yeah, I think I agree with you. That's a good way of putting it. So that's good. Yeah, but and also I wanted to point out is that if you follow me, and then I also will be doing follow me, meaning on Twitter. So it's basically too on IBM too. We also have to be doing like video series that we'll be talking to experts too in the field that we're trying to connect with, and say for example Josh Long, right, from Spring Pivotal. We actually have had some interview with him at DevNexus too just a couple weeks ago. So we talk about different things on Spring, but I'm trying to find him to talk more about database connectivity, because he spoke quite a bit too on some of the R2DBC, for example, the connectivity. And then there are also Oracle. There's somebody also talking about reactive like database. So I want to try to get him, and then we can kind of talk more too. And then so I will have these things on our video series on IBM Developer on YouTube too. So I invite you to kind of follow that. And I also tweet out if there are new like video series coming out, for example. So, but thank you for asking the question.
Thank you.
So, okay.
Hi. You mentioned that Vertex can interact with the other frameworks. Is
Yeah.
that an exclusive issue of Vertex, or can we interact with other implementations of Reactive using Spring React or all the other implementations?
Yeah, I believe that's a good question too. Basically, too, you can definitely let's say you're Vertex, and then you want to interact with other components in other languages or other frameworks, that you can do. But I think your question is about whether
Whether we can do the same with the other implementations, such as the Spring Reactor, or
can they kind of include
Yeah.
some of the yeah, that's a good question. A good question. Yeah, that I don't know exactly the answer, but I'll keep this in mind. I'll look that up and then I'll let you know. Yeah, we should connect. Yeah, so I mean, kind of follow each other.
Definitely.
Thank you. Thank you. Yeah.
You have mentioned two fields, let's say Rx in Java and
Yeah.
Reactor.
Yeah.
Which one would be like, these two might be competing one with the other.
Oh yeah.
Which one do you think is more feasible to succeed, or the
succeed?
one that has more followers if I had to
Oh.
choose which one I should go for?
Oh, okay. I see what you mean. I think to this day, I know that Rx Java is being used a lot in, say, it depends on your situation. I think if you're a mobile app, it's probably using Rx Java is probably easier in some sense, because it's, yeah, in some sense I think because there are more libraries, you can just include them and do your thing. That's what I think it would be. But for Spring, let's say if you are more with like JEE system, they're more enterprise-y kind of system, I think then you may want to go with the Spring Reactor because of its good integration with all the Spring framework kind of behind the scenes. I think that's what I would suggest. But it again, depending on the context the context of your system, then you can make a decision in there. Yeah. Okay. Yeah.
Any more questions? Okay. Anyway, after what's coming up next, you could ask whatever you want
Yeah.
during
That's
the
it.
networking and the pizzas.
Yeah.
So thank you, Mary.